Water. As Earth's crust cooled and solidified, water vapor condensed. It rained for 100 million years, and the oceans formed. For many years, most scientists believed that water was brought to Earth by meteorites in the early solar system. But that cannot explain the large amount of water in our oceans. There must be an additional source. While this is still a good hypothesis, other hypotheses have been proposed more recently. Lunar samples taken during the Apollo missions of the 1960s and 1970s showed that the water found on lunar soil particles matched water particles on Earth. This tells us that the Moon and Earth probably got water from the same source and not just from meteorites. This discovery suggests additional hypotheses about where Earth got its water. What is the source of our water? Could water vapor have been carried from the Sun to Earth and its moon by solar wind? Could it have been carried to Earth as the planets formed from other planets, such as Jupiter or Saturn, when their early orbits crossed Earth's path? There are several hypotheses that could explain where our water originated. Our water probably has more than one original source. 3/4 of Earth's surface is submerged in water. Water is fundamental to life on Earth. Why? A water molecule consists of two hydrogen atoms covalently bonded to one oxygen atom. The oxygen atom has more protons than the hydrogen atoms, so the hydrogen electrons are pulled closer to the oxygen atom due to the stronger electric force. The water molecule still possesses an overall neutral charge, but the oxygen side of the molecule is slightly negatively charged, and the hydrogen side is slightly positively charged. Water is known as a polar molecule because of the uneven distribution of charge. This is important to the behavior of water and its impact on life. The polarity of water gives it several important properties that allowed life to emerge on Earth. Water moderates temperatures in its surroundings. Water dissolves most substances. Water attracts other water. It is cohesive. Water has a very high specific heat. It takes a lot of energy to raise the temperature of water even a few degrees. This means that temperature on Earth's surface is moderated by its water. The temperature doesn't get too hot or too cold. Why is this important in the development of life on Earth? Water is sometimes referred to as the universal solvent because of its ability to dissolve most compounds. Life's chemical reactions need to occur in solution. Nutrients can dissolve in water, allowing chemical reactions to occur. The dissolving of compounds in water also lowers its freezing point. The polarity of water molecules cause them to be attracted to each other and to other molecules. The positive or hydrogen side of one molecule is attracted to the negative or oxygen side of another. The bonds are between molecules, so they are called intermolecular bonds. Don't confuse intermolecular bonds with the bonds between atoms that form molecules. Covalent bonds are strong bonds between atoms. They form molecules from separate atoms. Intermolecular bonds are much weaker. They don't form molecules. They connect molecules together. They play an important role in the characteristics of matter, including water. The type of intermolecular bonds formed in this case, hydrogen bonds, are so named as they occur because the hydrogen atom's electron is attracted more by a stronger atom, oxygen, polarizing the molecule. Two of the types of attraction that result from hydrogen bonds include cohesion, which is the attraction between water molecules, and adhesion, the attraction between water molecules and non-water molecules. Among other things, this property allows plants to pull water up through their roots, small insects to walk on water, ice to float, and water bends carbon, which are organic molecules, into specific 3D shapes. Cohesion is a factor contributing to the high specific heat of water.